In this lesson, we're going to look at solving problems dealing with molar concentration. The formula we are going to use is C equals N over V, where N is the number of moles of solute and V is the volume of solution in liters. Let's first look at how we rearrange this formula. So C equals N over V is our one form where we're looking to solve for concentration. If we're looking to solve for moles, what we want to do is we want to multiply both sides by V, and that will isolate our N. So N is equal to C times V. If we're looking to solve for our volume, we can simply switch the C and the V. So V is equal to N divided by C. So these are the three forms of the formula that we are going to use. Just some tips before we look at solving problems. Always make sure your volume is liters, so you may need to divide your milliliters by 1,000, as you will often be given your volume in milliliters. Be sure your amount is in moles. If you have a mass, you will need to calculate moles first, and sometimes you are asked to calculate a mass, so you'll have to use your molar mass. And always include units in your final answer and round it to the correct number of sig figs. And our units are going to be moles per liter, or sometimes just a capital M. In this first example, it's asking us to determine the concentration of a solution of sodium chloride if 1.5 moles, so our moles are 1.5, are dissolved in 500 milliliters. So again here, we're going to need to divide by 1,000, so move the decimal 3 spots. So we have 0.5 liters. C is equal to N divided by V. So we have our 1.5 moles divided by our 0.5 liters. So we get 3.0 moles per liter. In our second example, it's asking us to determine the volume. So we're looking for V of a 0.35 molar, so that can be moles per liter, that contains 0.50 moles. So V is equal to N divided by C. So we take our moles, 0.5 moles, divided by our concentration of 0.35 moles per liter. And you can see the moles will cancel, and we get 1.4 liters for our volume. Our next example is asking us to determine the amount, and remember, amount is asking us for moles. We're given 450 milliliters, which we want to divide by 1,000 or move the decimal 3 spots to convert to liters. And we have 0.25 moles per liter. So to figure out moles, we do concentration times volume. So we have 0.25 moles per liter times 0.540 liters. So our liters cancel and we get 0.11 moles. In this next example, it's asking us for the mass of sodium chloride. So remember, sodium chloride, NaCl, is required to make 500 milliliters. So again, we'd have 0.50 liters. And we have a 0.45 mole per liter solution. And we're asked for mass. So first, we're going to figure out moles by doing our concentration times our volume. And so we get 0.225 moles. And then we're going to calculate our mass by doing moles times molar mass. I'm running out of space, so I'm just going to write it down here. 58.44 grams per mole would be the molar mass. Moles will cancel, and we're left with 13.1 grams. So in order to make 500 milliliters of a 0.45 mole per liter solution, we would need to weigh out 13.1 grams of sodium chloride and dissolve it in 500 milliliters of water. In our last example, we're told we're starting with 45 grams of calcium hydroxide, so that's a mass, and it's placed in a 1 liter volumetric flask, and it's filled with water. What is the solution's molar concentration? So we need to find moles, but this time we're going to be finding moles by doing the mass divided by the molar mass. And calcium hydroxide is CaOH2. If you need to review your naming rules, please find the appropriate video. So we're going to do 45 grams divided by our molar mass, 74.1 grams per mole. So grams cancel, and we're left with 0.607 moles. Always keep extra significant digits in your intermediate steps. The second part of this is we're going to do our moles divided by our volume in liters. So we get 0.61 moles per liter. So what that means is that if we take 45 grams of calcium hydroxide and dissolve it in 1 liter of water, our concentration would be 0.61 moles per liter. So that concludes our review of how to solve problems that involve amount or molar concentration. You will learn how to make solutions in your laboratory activity in class.